This isn't drone footage, this is data. And this isn't the future of drones in construction, this is now. Hello everyone, my name is Gord. I am a licensed and insured drone operator in the Greater Toronto Area in Ontario, Canada. Today, we're going to take a look at what drone mapping looks like. I use a piece of software that creates an automated flight that flies a grid pattern back and forth across the land. The camera is looking down and it's taking a picture every 2 or 3 seconds. And as those pictures are accumulated, we then put them into a supercomputer and they are crushed together to create what amounts to essentially a high-res Google map. So let's get into this. What we're looking at here is a large earthworks project, and I flew this site multiple times over a couple of months. A 2D orthomosaic map, basically a stitched high-resolution aerial view of the entire site. Now this is where it gets interesting, because now we're not just looking at a picture, we're tracking change. This piece of software lets me compare different dates and actually watch the land change over time. And that's where the value is. Not on one flight, not on the drone. The value is the consistency over time. Now this is great. We have a 2-dimensional map that we can look at and we can see different parts of the land. And this gives construction planners and engineers a chance to say, okay, there we're going to put that. It really gives them a chance to see the land. But there's another layer to this. This software builds an elevation map. Here we're looking at red is higher and blue is lower. Now this site, we can put a distance line across it. There's a huge slope from one highway to the other. And of course, when you're building a building, one of the first places you start is a level pad. So of course, something has to give here, and that's what we call cut and fill. So now you're not just seeing the site, you're starting to understand it. You can see the grade happening at that moment in time. That information is hard to grasp from the ground. It knows how high things are on that map in terms of elevations. And within that, the software can create volumes. Now, this has become extremely important in construction. When you're moving dirt to create something, a building, let's say, you're digging down for the base structure, where does that dirt go? Well, they create stockpiles, and eventually that dirt is either going to be reused somewhere else on the site, or it's going to be moved out. In this case, it's about 26,500 cubic meters of material. Now that's not a visual, that's a number you can actually use. Dump trucks in Canada typically carry 15 cubic meters each. That's 1,700 dump truck loads, which is a lot. So you can see how this information from the drone becomes super important to construction managers and engineers as they're working the land, getting it ready for the next stage of construction. So far we've seen the 2D orthomosaic. This is the 3D model, what people often call a digital twin. It's a full representation of the site as it actually exists. You can measure area, distance, and volume. Within this software, you can also overlay architectural plans on top of the drone data. So now you're not just measuring, you're able to inspect, verify, and understand the site without being there. Powerful. But it doesn't end there. In some cases, the full 3D model gets exported as a point cloud, which can be drawn into AutoCAD Civil 3D, which of course is used by a lot of BIM and VDC departments within construction companies. So there you have my take on drone mapping. It's not footage, it's data. And this is quickly becoming the standard. For me, this is the future of drones, and it can be real value on construction sites. Thanks for sticking around. See you on the next one.